We should know, hopefully, that there's a big difference between a stable flow, like coming out of a slow tap, and water coming out of a hose, like in this little image here. So this water is coming out with a lot of force. If you've ever, well, been stupid enough to have people spray hose water in your face, you'll know it's pretty sore in comparison to, say, even a shower. That water is relatively stable in comparison to hose water. So fluids coming out of different places will naturally have different flow rates. Let's say here, the garden hose will spread out more water than a leaky pipe. So we also know that because we can actually accurately aim the water at a target, we know that it's at least somewhat stable, like counterintuitively, despite the fact that there's a lot of force behind the water, similar to rivers and if a dam bursts, for instance. So we know that the volume expended over time is proportional to the area, and obviously the larger amount dispersed, the naturally higher the cross-sectional area will be. So there's a way of determining and actually notating these different kinds of flows. One of them is called laminar flow, which you might have seen if you say you're a big fan of what's his name, Captain Disillusionment, who did a whole video discussing what's known as idealistic laminar flow, which in some cases can be achieved. Uh, and when a flow is chaotic, we call it turbulent. Now, that word might ring a bell. I did discuss in the intro that we'll be talking a lot about the dynamics of airplanes, and as such, this is where turbulence comes in. So these little spirals at the back are called vortices, and they're essentially columns of air that are rotating really fast around a disturbance in the air, which in this case is our plane. So it is a common occurrence, and it especially occurs in torrential and stormy weather when there's a lot of force behind the water, and there's a lot of, well, the water inside of the clouds are tightly compact and are also releasing. So there's actually a lot of water in both the compression and the release of water and precipitation in the clouds. So this occurs when the plane cannot remain level in flight because there's a lot of shear stress forces acting on the plane. However, planes are obviously built to withstand these large forces, or well, conservatively large forces compared to the plane. So it might just be slight bumps, but it's not anything to be worried about. So it's mostly just a slightly uncomfortable experience. So that's a lot of stuff theoretically, but how do we do this mathematically? Well, that's what the next video is about.